All right, our new lesson is on coordinate grids, and our objective is to reinforce your or the student's understanding of coordinate grid structures and vocabulary. So what is a coordinate grid? Well, in this case, a coordinate grid is a rectangular coordinate grid is used to name points on a plane. And notice the spelling of plane, it's not like aeroplane, but a flat surface that goes on forever. So this is technically a flat surface that goes on forever. Now, what is a coordinate grid made of? Now, coordinate grids are made up of axes. The two number lines form the coordinate grid. And if you're looking at the number lines, there goes left to right, and they go up to down, up and down. Okay, so those are the two main parts of the grid. Let me zoom in a little bit so you can see it a little bit more clearly. There's the numbers. You see it going from starting at 0, and starting at 0, going up to 10, and then it goes on into infinity. It doesn't stop. And then obviously down 0, down negative to 10, and obviously negative into infinity. And then going up, you have positive 10, down you have negative 10. Both of those going off into infinity. Okay. Every point on a grid is named by two numbers, and they're called an ordered pair. And they look like, this is how they're notated. So you would have, say I was at 4, 2, okay? The first number is on the x-axis, and the second number is on the y-axis. So let's go ahead and find our 4, 2. Okay, so let me zoom around here a little bit. Okay, so 4, 2. Here's the x-axis right here, and my point 4 is right here. Now, and then I have to go up 2 for the y-axis, so I go 1, 2, and that's where my point goes. So 4, 2. Ooh, I need to get something darker so you can see it. 4, 2 is right there. Okay, where those lines intersect. Okay, now that's an ordered pair. Going back over to this side, we have next is the origin, is the intersection of the two lines at their 0 points. So the origin is actually going to be at, let me get my colors back, 0, 0 for both x and y, and 0, 0 is going to be a right there. Okay, so that's called the, let me move back, that's called the origin. Now, the axes, there's two of them. The one we're going to talk about first is the horizontal axis, the number line that goes left to right, often called the x-axis. So this is our horizontal x-axis, left to right. And then the vertical axis, the number line that goes up and down, is called the y-axis. So this is y. So it's important to remember, x goes across, y goes up and down. When you're looking at your ordered pair, the x is the ones that go left to right, and the y's are the ones that go up to down, up and down. Okay. Now, as you can see, I've drawn a number of dots on this grid, and they actually represent my initials. So if I draw a line, let me zoom in to the first one, to M. Here I have dots. I'm playing dot to dots now. I have my M. I have my J. And let me zoom down, and I have my S. S is the biggest one. Okay, So now let's look at each one and what the coordinate pairs are. Whoops, I didn't mean to do that. What the coordinate pairs are for each letter. Okay. So for my M, let's start at the bottom here, and I have, for part of my M, I have -8, 1. So I would go over, let me zoom. So for my M, I have 8, -1 for my first dot. Let's see if I can do this all on one screen. My second dot up at the top here is -8, 8. -8, 8. My middle dot right here is -5, 4. -5, 4. Then I go up here and I have -2 down at the bottom, 8. -2, 8. And last but not least, this guy right here, I have -2, 1. -2, 1. And that's the letter M. Okay. How much space do I have left? See, I've run out of space already. So let's move this over a little bit. And let's do my J. What are the coordinates of my letter J? Zoom a little bit more. Come on, zoom. There we go. Okay. Maybe a little bit harder to see. But my J starts at 1, and I go up to 4. So my J is going to be in the positive range for pretty much everything. 1, 4. And then I've got, next I have 2, 3. 2, 3, which was this dot right here. The next dot right here is 4, 3. 4, 3. And my next dot right here is 5, 4. 5, 4. And up here, right up here, I have 5, 9. 5, 9. So those are all the dots that I made to make the letter J. Now, the letter S has a lot of dots, so I'm going to hit pause and I'm just going to show you what they are. Alright, as you can see, this S has a lot of dots to cover, so I'm going to have to zoom around a little bit. So I started down here, and I have -10, 2, which is right here, -10, 1. Then I go down to -11, 2. And as I go through the rest of the S, I have -11, 5, -10, -11, 5, -10, 6. And then I jump up to -7, 6, -6, 5, -6, 2, -5, 1, -2, 1, up to -1, 2. And then I have -1, 5, and then lastly, I apologize for how much zooming, and I'm hoping I'm not making you guys nauseous by looking at this. I have, last but not least, I have -2, 6. So overall, let me zoom back to my initials. Overall, you can see that it's how the coordinate grid works. And you can make up your own initials and however you want to do that on your own grids. The big idea, what is my big idea? Coordinate grids are often used for navigation, even with GPS systems, and particularly to measure distances in space. So they actually are useful and are commonly used today. So, but they go back actually many centuries. So you can actually look up and do an interesting research project on the origins of coordinate grids. There's a guy named Archimedes who was actually really interesting from Greek times, who talks a lot about coordinate grids and uses coordinate grids. And I want you to, for your homework, complete Math Journal pages 292 and 298. Okay? And I will see you in class.